Hello everyone and welcome to lesson 6.2.5. What do similar shapes tell us? Working with corresponding sides. Today we're going to step away from the coordinate grid for a lesson and we're going to focus on scale factor and dilation. We're going to focus on the side lengths. So here we go. Problem 6-86. With your team, find the scale factor between each pair of similar shapes. That is, what are the sides of each original shape multiplied by to get the new shape? This is all about direction today. Okay, you have to pay attention to the direction in which you are going. I want you to notice we are focusing on this right here. Where did you go? Where did you come from? If we're using the book's vernacular, this is the new over the original. Okay? Where did you go? Where did you come from? Okay? You're always landing on top. So I want you to notice original to new. So what do you multiply by to go from the new shape, from the original shape to the new shape? Well, focus on the side lengths. What do you multiply by to get from 6 down to 3? Well, we think about division. Divide by what? Oh, that's a divide by 2. But what do we multiply by? We multiply by a half. And notice that is true with the corresponding side on the bottom. Notice 12 times 1/2 is 6. Now notice, because we are starting with the new shape, 3, over the original shape, 6, notice that gives me the fraction 1/2. I want you to notice you can always find the scale factor by comparing two of the corresponding sides. If you know you've got the right-hand side, you can just write a fraction. 3 over 6 simplifies into 1/2. Sometimes it's really easy just to look and see and know. But problems are not always as straightforward. We don't know what the multiplier is. I want you to focus on the sides that correspond. But before we move on to B, I do want you to notice how direction matters. Notice, if I went this direction, notice that my multiplier just changed. Notice that if you change direction, you have to change the way you're thinking. Notice that it's still 2. The relationship between 2 and 1/2, those are called reciprocals. Okay? 1/2 and 2, they are opposites. And depending on the direction, that's going to help you complete this problem. Now, let's go ahead and find the scale factor in problem letter B. All we need to do is write a fraction, new. Which number is my new number? 5. Which number is my original number? 4. Notice this shape got bigger. If this shape got bigger, notice my number is greater than 1. Notice this shape got smaller. And my multiplier, also smaller than 1. Okay? This is a key factor when we're doing scale factor. Does it matter which pair of corresponding sides we use? Yes, it does. Okay? Because smaller to bigger, bigger to smaller, we need to pay attention about direction. What I want you to write is when a shape grows, the scale factor is greater than 1. When a shape shrinks, it's getting smaller, the scale factor is less than 1. This is a key relationship. When your shape is increasing in size, your multiplier, your scale factor is also greater than 1. When it is shrinking, getting smaller, your scale factor is less than 1. Pause the video if you need to finish recording this sentence. In 6-88, now you are focusing primarily on this graphic. You have a graphic on your page, okay? I'll tell you what to do in just a minute. This study team is working to find the scale factor for the similar triangles at right. Claudia set up this ratio, Isaac set up this ratio, and Paula set up this ratio. And the question is, does it matter? Does it matter which side you use? Now, previously we said, yes, it matters, like the sides we use in the direction. We are going in this direction, from the original to the new, landing on top. So that's why all the larger numbers are on top. But does it matter which side we use? Top, bottom, left, right. Well, if we notice that they each chose a different pair. No, you do not have to write this down. I am just pointing it out. They chose a different pair. Okay? Is the scale factor any different? Because I want you to notice 14 over 4 can be simplified by dividing by 2, and you would end up with 7 over 2. If you took 28 eighths and you divided by 4, you would get 7 over 2. If you took 21 sixths and divided by 3, you would get 7 over 2. I want you to notice the scale factor is the same. Underneath, I want you to write this sentence. It's not written down. Listen to this sentence. It does not matter which pair of corresponding sides we use. It does not matter which pair of corresponding sides we use. Period. It does not matter which pair of corresponding sides we use. Period. Each pair should equal the same scale factor. Each pair should equal the same scale factor. Notice that each of these fractions that we used is 3.5 times bigger. That's 7 divided by 2, 3.5. Each side is 3.5 times bigger. And notice the way that I found that was writing each as a fraction and simplifying it. Each pair equals 3.5 times bigger. Have that written down underneath. Off to the right-hand side. Dividing a fraction is the same thing as multiplying by the reciprocal. What we need to recognize is sometimes we need to drive forward and sometimes we need to drive reverse. We need to think about direction. If we're going forward or we're going backward. Notice that this is the problem that we had previously, okay? Now notice that we discovered the scale factor 5 over 4. We discovered that scale factor because we have 4 times the scale factor, 5 over 4, and we got the side length of 5. But what do I do? I'm continuing to go in this direction. So what I need to be able to do is use the scale factor to find the missing length, x. Just so you know, this is on Thursday's test. We need to pay attention to direction. So I'm going to take my number, 6 times the scale factor, 5/4, and that is going to give me the new number x. Now when you multiply fractions, I set it up like this, so they both have a numerator, they both have a denominator. And you can either multiply first, then simplify, or you can simplify first and multiply. So here we go. I'm going to multiply straight across. 6 times 5 is 30. 1 times 4 is 4. I can simplify this by dividing by 2. That's going to give me 15 over 2. 15 divided by 2 doesn't go in evenly, but I know it does give me 7 1/2. you could write 7.5. That would also be acceptable. Okay? Now that was driving forward. We're following the original to new. But what if I'm going in the opposite direction? Okay? When we're going in the opposite direction, I need to think about scale factor differently. If I'm going in this direction, notice my new landing spot is 4, and I started with the number 5. What do you notice is similar about these numbers? Same numbers, but opposite. This is the reciprocal again. Okay? We talked about it in the beginning, but direction matters. So what I'm going to do is I am going to use this scale factor, and I'm going to work my way back. So I'm going to start at 10, use my scale factor of 4/5 to solve my problem. I multiply straight across, and I get 40. I multiply straight across, and I get 5. 40 divided by 5, y equals 8. Notice, direction matters. Scale factor, it's really similar because they're the same numbers, but they're in opposite locations because we're going in the opposite direction. You have to pay attention to that. So what your job is to pay attention to what the scale factor is and how to get there using the right multiplier. Okay? Now, you have 4 problems. Okay? The first thing that you need to be able to do is you need to be able to pick out the scale factor. I'm going to do letter A. You're going to do B, C, and D. Okay? Here we go. First thing, find the scale factor. Oh, Mr. McCoy, it doesn't tell me which one is the new and which one is the original. You choose because it doesn't matter. See, look. Here, I notice that the left-hand side is there. I notice that I can find the missing multiplier. Oh, I know that 11 times 3 is 33. So, let's use that scale factor, the right-hand side going to the right-hand side. I use that scale factor of going 3 times bigger. 9 times 3 is 27. Now, if I need to go in the opposite direction, what is the opposite of multiplying by 3? Well, if I'm trying to go this way, I should change colors because I'm using the opposite. Let's change to an opposite color. I'm going that direction now. So instead of going from 11 to 33, I'm going smaller. Well, I could multiply by 1/3. But remember, multiplying by 1/3 is the same thing as dividing by 3. So I could think, well, instead of driving forward times 3, I could drive backward, divide by 3. If 33 divided by 3 is 11, then 39 divided by 3 is 13. Scale factor is all about direction. Is it getting bigger? Is it getting smaller? If you're trying to make it bigger, multiply. If you're trying to get smaller, divide it. Unless you're dealing with a fraction. If you're dealing with a fraction, driving forward was 5/4. Driving backward was 4/5. You have to pay attention to direction. Direction matters. Now, thank you for coming to today's lesson on scale factor. Thanks for keeping caught up with your math. I'll see you in our next video lesson.